particle moves such that at time t seconds, t being greater than or equal to 0, its position vector is r meters, where r is equal to cos ti plus sine tj. Again, I like column vectors, so I'm always going to write that as cos t sine t. Show that the velocity of the particle is perpendicular to the acceleration. So the velocity, let's make that look a bit more like a v, is going to be negative sine t cos t. The acceleration then will be negative cos t and negative sine t. V dot A would be negative sine t cos t dot negative cos t negative sine t, which is equal to sine t cos t take away sine t cos t, which is equal to 0, and that does the trick. Find the Cartesian equation of the path of the particle. So what we have is that x is equal to cos t and y is equal to sine t. That's just using the components up here. Now we want to eliminate t between these two equations. Now remember that cos squared t plus sine squared t is equal to 1. That's one of your Pythagorean identities. Therefore, x squared plus y squared is equal to 1. So what we have is a circle, radius 1, center at the origin. Sketch the path of the particle below, indicating the start point and the direction of motion. So let's think about the fact that r was cos t sine t, and that v is equal to negative sine t cos t. And then what we need to do is draw a circle centered at the origin. That's pretty okay. And radius 1. Now when t is equal to 0, let's think about this. R would be equal to cos 0 sine 0, which is 1 naught. So that is the start point. And then let's think about what happens if we think about, well, v of 1. That's going to be negative v of 0, negative sine 0, cos 0, which is 0, 1. So that would be travelling upwards, and that suggests to us that the particle is going to go around in this direction, except I've drawn that last one the wrong way around. There we go. State the period of the motion of the particle and the distance travelled in one period. Okay, so if r is cos t sine t, cos t and sine t both have a period of 2 pi. So t is going to be 2 pi seconds. The distance travelled is just once around that circle. The circumference of a circle is 2 pi r, and the radius was 1. So it's going to be 2 pi meters. Now you could have got that from the integral. The integral from 0 to 2 pi of the modulus of the velocity, and the modulus of the velocity in this case would be, so velocity is here, the square root of sine squared t plus cos squared t, Well, that's the integral of 1. And so that is t to be evaluated from 0 to 2 pi, which again is 2 pi.